Conjugates are basically vertically opposite mirror images of each other.
First, let us learn about rotation in the I, j and k planes. So imagine an ant which has to travel at the point 3i plus 5j plus 7k on the above bowl.
Conjugates are basically vertically opposite mirror images of each other. For every point in the real object, there is a vertically opposite mirror image in the form of a complex conjugate. It's like a reflection of an actual object in a point. Now, let's look at another example of complex conjugates. Just look at this clock. Let's say the length of the needle is 5. Now, when the needle is perfectly horizontally inclined, pointing towards the right, its length is given as just a positive 5. When the needle is pointing in the opposite direction, now its position is given as minus 5. When the needle is pointing upwards, we give its position as 5i. Now, if the needle is pointing somewhere in between, its influence gets divided into two parts: its horizontal component and its vertical component. In other words, its real and its imaginary part. For example, at 1 o'clock, its real component is 2.5, and its imaginary component is 4.33i. The angle at which the needle is at this point can be calculated as tan inverse of 4.33 divided by 2.5. In this case, the answer is approx 60 degrees. Now let's look at the complex conjugate. Its value is 2.5 minus 4.33i. This is when the needle is pointing at 5 o'clock.
But first, what if there was an e-book that explained major concepts of math using simple and everyday examples and analogies? What if sine theta is a measure of how much perpendicular two forces or objects or influences are with respect to each other? So a roof which is perpendicular to the flow of snow, won't it collect more snow than a roof that is less perpendicular? Now, coming to cos theta. Cos is a measure of how much parallel two forces or objects or influences are with respect to each other. Say two forces push a drum. Won't the maximum effect be when these forces are acting parallel to each other? Complex numbers. They come into math whenever one parent force or influence gets divided into two daughter influences. You can call one daughter influence as the real part and the other daughter force as the imaginary part. What if the base of logarithms is the rate at which change takes place? What if log of a number gives you the cause for every effect? In calculus, dx means keep adding along the x-axis. D means keep adding along the y-axis. Dozen means keep adding along the z-axis. D theta means keep adding along a vertically curved plane. D psi means keep adding along a horizontally curved plane. DH means keep adding along increasing height. Doctor means keep adding along increasing radius. Also, what if integration and differentiation are reverse processes of each other? Add disks one above another along a height, you get a cylindrical structure. Thoughts integration. Remove disks along height, you get circles. Divergence is the rate of change of a quantity, for example heat, along the x, y and z axis simultaneously. What if curl is a measure of how much a field can make you spin? What if I, j and k in the formula indicate different planes of rotation? What if the diagonal of a matrix is the axis of rotation of a matrix? What if all these intuitive examples and understanding is explained in one single e-book? More such concepts explained intuitively. Link is given below in description.
Reason that the real part is a smaller number, that is 2.5, and the imaginary part is a larger number, that is 4.33, is because the needle is more vertical than horizontal. The spokeswheel is an example of different complex conjugates, which are mirror images of each other. But not every spokes arrangement on wheels will form complex conjugates. As you can see in this picture, there is no vertical symmetry when the image is cut into half. So no complex conjugates. Further, let's see complex conjugates in 3D.